This conference will now be recorded. This conference will now be recorded.
Hello, everyone. Good morning. So before we begin, let's start with introductions because we will keep interacting with each other either on this call or through Slack channel. So let's begin with Chandrakant.
Yeah, hi everyone. This is Chandrakant. I have 6 years of IT experience, and then I work as a IT analyst, and basically I take care of identity access management and a few cloud ops.
Thank you. Harish.
Asia. I have a total of 10 years of experience in IT, and I'm working as an SAP HCM consultant in Microsoft.
Thank you, Harish. Funny SVD. Hello. Okay, I think he has some issues. Prasad, could you introduce yourself, please?
My name is Prasad, currently working in Cognizant.
Hmm.
Fresher now. I joined last before 8 months.
Okay, cool. Okay, Ramana.
Hi, Kiran. Hi, everyone. Good morning. I have over 10 years of experience, and currently I'm working on SharePoint technology, planning to move over to Azure. So I work for Deloitte.
Thanks, Ramana. Sai Krishna.
Hey, good morning. I have some around 6 years of testing experience. That's only in manual testing, and I'm looking for the change to the Devops side.
Okay, so what is your role?
I'm a senior tester. Only it's a
Okay.
manual testing.
Okay, you're into QA. Okay, great. Okay, I think that's great. We have people from various backgrounds. Okay, so before we begin, I would like to clarify on a few things that I received in the form of feedback in the last session, or the demo session, in fact. So let me start sharing my screen. Okay, let me know when you see my screen. Okay.
You can see it.
We can see your screen,
Okay.
Kiran.
Yeah, cool. All right. So the course name is, you know, DevOps Azure with DevOps, or you could also read it as DevOps with Azure. So the intention is to teach or make you understand Azure cloud concepts okay, along with DevOps practices. Okay, let's just keep this in mind. So the keywords here is to understand DevOps and DevOps tools that we've talked about, like the infrastructure as a code tool or the CI/CD tools. Okay, so keep this in mind. And besides that, the thing I would like to talk about is another product from Microsoft, which was until recently called as Visual Studio Teams Services. Okay, this is like two to three tools. Like you have a built-in CI/CD tool. Okay, when you might ask what is CI/CD tool, we'll learn that about uh, in some time, which is similar to Jenkins. Okay, then you had something like a code repository, which is similar to your let's say GitHub, and then you have its own project management tool, which is called which is similar to Jira. Ram, you may correct if I go wrong anywhere. So this was recently so until recently it was called as Visual Studio Team Services. This was one of the offerings by Microsoft. This is again a cloud-based product, meaning you need not install anything on your data centers in your local servers. There was another version called as TFS, Team Foundation Services, which is an on-premise installation. Like you can install on your own and you can manage it by yourself. But later, what happened was this Visual Studio Team Services has been renamed as Azure DevOps. Okay, so the name of the product itself is Azure DevOps. So what I'm trying to say is we are not going to learn only Visual Studio Team Services. This will be only a part of our course, but what we are going to learn is Azure Cloud, that's Microsoft's Azure Cloud, with DevOps tools and practices. Is because the name might, does that make sense? It might be DevOps. Some of you might think it's only Azure DevOps. No, we're only talking Azure DevOps as one of the components. Um, so another feedback am I clear, or did I really confuse you guys?
Kiran, Harish here.
Yeah, yeah.
Quick question, Kiran. See, I'm a part of this Azure training before in this career IT only. I had taken from Praveen. Okay.
Hmm.
In that classes, I learned up to the CI/CD pipelines and all,
Okay.
Azure Cloud and the
So you also
CI/CD.
talked about the. Okay, yeah.
Okay. The other thing is like I'm actually looking for Azure DevOps thing, Azure with DevOps thing. So is it like I need this coding part? Is that required for me?
So as I said, we are talking DevOps here. So when we talk DevOps, there will be some sort of coding,
Okay.
need not necessarily programming, but you will need to do a lot of typing in the sense that you will have to write code, but you will
Okay.
not build the code from the scratch. You will use the existing modules. You'll just make some changes to them. You'll just replace some values and use it. So it's not that you'll have to learn a programming language altogether, but yes, if you see today's job openings anywhere, you will see that they will ask for some sort of automation, be it
Okay.
Linux shell scripting or be it Python. So what we are going to do in this course is we are going to learn some Linux. We're going to learn some Bash scripting. So my role ends where I'll teach you how to create scripts, how do you take input, how do you redirect input, and how do you put them in files and stuff like that, or even to some extent of for loops and if loops. The other part
Okay.
lies with you. How do you take that and practice extensively with other use cases? There are a lot of practicals available online. So
That's
today
true.
I would say going forward everything would be about automation. Like you could ask people who are working in the uh, DevOps roles or operations roles. The emphasis has always been on automation, and the automation can be done only through coding. Okay,
Okay.
so we are not going to be programmers. We are not going to develop new modules or use frameworks. frameworks extensively and do something. But what we are going to do is we will use the existing frameworks, use the existing tools, and
Mm-hmm.
understand
Okay,
Azure
got it.
concepts, Azure cloud concepts, and apply to them. So, for example, if you want to create 10 VMs, okay, you would not want to go to the Azure website and click on create and so on and so forth. Instead, you'll create a script which can be reusable, and you'll start using it. Okay,
Okay,
so that's important for, and many organizations are adapting this path of DevOps right now. In fact, there are organizations who might call themselves who might have DevOps teams, but they're not doing the core automation. They're still trying to move
okay,
towards that side. Okay, so my point is this: without automation, DevOps doesn't make much sense. Okay,
okay,
so the automation is purely done through your coding. Okay, and that
got
coding need
it.
not necessarily begin from scratch. You'll have the tools available online. You'll just need to copy paste, replace some stuff, but before that you need to understand what you're doing. That's my point.
Okay. And last time it was like a .NET based kind of thing. Is it now .NET or something Java based training, Kiran?
So that will form only when we come to the CI/CD. Maybe we can take I mean, my idea is to implement Java applications because we are dealing with Linux servers.
Okay,
Maybe for one, maybe we can have an additional class or something with Windows Server and a .NET .NET code, .NET application.
okay.
All right.
All right, Kiran, yes, that's all one.
Yeah. Thanks, Harish. Any other questions, guys?
So for this is I don't we use any PowerShell scripting for automation?
So as I said, we are going to use Linux, which is much more widely used for all Linux servers. Um, we're not touching much on PowerShell. So this is how it goes. So the scripting is the concepts in scripting are same. The syntax might vary, but from the little research the career ID did and I did, we definitely know that the openings for Linux are high in the market, and people with shell scripting skills definitely have an edge over PowerShell or simply Windows knowledge. That's my intention. So if you say you have good shell scripting knowledge and the interviewer interviews about shell, I mean, from the Linux scripting perspective, and they understand that you're good, it doesn't matter if they're using PowerShell or just shell, they'll hire you because shell scripting itself teaches you what to do with the uh, how to do automation with scripts.
Okay,
Yeah, maybe you could try learning PowerShell on your own. And
okay.
yeah, the thing today is, even you might have seen this, you might have seen this, Microsoft, which once called Linux virus, I think it's Paul Brummer, who called it Linux is a virus. Today, they're openly saying that Microsoft loves Linux. They have announced it in one of their big conferences that, yeah, they put something like this: Microsoft loves Linux. So even Microsoft is moving towards open source technologies, and they're giving their platform to be much more extensible with the open source tools uh, you know, like Java, Jenkins, and all this stuff. So yeah, Linux definitely will have edge over other operating systems. Okay. Any other questions before we start? Okay. Yeah, another feedback I received from a few members is, see, this Visual Studio Team Services are what we call Azure DevOps. This is like an umbrella of services which has three services: CI/CD, code repository, okay, and its own product management. So some people said, instead of learning this one service, why can't we individually learn Jenkins, okay, and also GitHub? I'll teach Git anyway. Git version control is part of this course, okay, uh, and maybe something similar to Jira or any other project management thing. So this is the feedback I've received, because Azure DevOps, maybe only some organizations might be using. There might be organizations which are using Azure Cloud, okay, but they're using all the open source Azure Cloud only to host their servers and storage, but they might be using all the open source tools like Jenkins, GitHub, and version control, because VSTS has its own cost. Okay, not that Jenkins and GitHub and Jira doesn't have, but they do. Uh, uh, so yeah, so I leave up to you. Maybe I'll send an email, or we'll start a Slack channel where we'll have a poll and decide whether we want to go with the Visual Studio Team Services, or Jenkins plus GitHub kind of integration. Okay, so yeah, I think that's about me. Before we begin the course, if you have anyone else has any questions, please go ahead and ask me before I go to the uh, cloud section, introduction to cloud rather.
What are the softwares that we need to install?
Okay, that's a good question. So if you are using a Windows machine, you'll need to have something called as Git Bash, which is primarily to use Git version control, but you could use it to SSH into Linux machines. Okay, you could also practice some of the for Git version control, obviously. You could also use it for some basic Linux commands, because this is like a Linux system within your Windows system. So the tool name is Git Bash. So this will help you into this will help us connecting into Linux machines. Okay, and another tool we will install a little later is a command line tool called as Azure CLI. Okay, we'll install Terraform. This is again mostly a command line tool. We'll also we'll install Terraform, and rest else everything else we'll do it on the servers itself. Okay, so that way you will also learn the Linux package management well. Yeah, I see only these things. Everything else would be mostly web-based services. Okay, so even if it's your organization's laptop. Yeah, sorry.
How about Visual Studio?
Visual Studio, we are going to use the cloud services. So that's a web-based service. You need not install anything.
Okay.
Okay. All right. Shall I proceed now? Okay. I think most of you might already be familiar with cloud and heard what it is, but I would just like to give you a brief overview of what cloud is. Okay. So okay, let me ask you guys, anyone. So what do you think actually cloud is, or in terms of cloud computing? Not the generic term cloud, but what do you think actually cloud is?
The resources which can be accessible from anywhere.
Cool. Anyone else? Okay, yeah, as Raja said, cloud is nothing but it's about computing resources that can be accessed from anywhere. That's one of the primary characteristics. But when you talk about cloud computing in a formal sense, is the on-demand availability of computing resources without the direct active management by the user. In other words, cloud is a collection of data centers managed by a cloud provider, and users can rent resources on a pay-as-you-use model without the upfront cost. So this is the important point: without the active management by the user, in the sense that you don't manage the underlying infrastructure. You don't worry about what's there in the data center, how is the server configured, is there power backup, and all that stuff. So you don't directly active the underlying infrastructure, but you could create resources on demand. For example, if you require 2 servers to install your operating system, to install your application, you would simply go to the cloud provider's website and click on create new resources. So, and another important part is you pay as you use. So there is no upfront cost. So if you have to buy 2 servers to run your applications, you need to first rent a room, you have to build the cooling and everything else. But when it comes to cloud, you just do not pay anything upfront. You can start using for zero money, and as you go on using, you'll pay only for, it's like your electricity, you pay as you use. All right. So what's the brief history of cloud? Okay, the term cloud as a metaphor for virtualized services, in the sense, as we spoke, these are all virtualized services, right? So it was used since the time of telescript, which was developed like in 1994. Telescript was initially thought to be the cloud, which was a time sharing machine. Then the journey of modern cloud, the cloud as we know today, has begun with the launch of Amazon's AWS. So AWS was launched somewhere in 2002 or 4, I guess, but actually the formal launch and the market adoption started in the year 2006. And they had three primary services, which is their S3 cloud storage, their simple queue service SQS, and their elastic cloud compute EC2. Okay, so that's where the actual modern cloud began with the Amazon's AWS. And Google introduced its Google App Engine, its first cloud offering, in 2008. Google's suite of cloud services are called Google Cloud Platform. So today, initially Google launched it as only an app engine, meaning you give your code, they deploy the code in their servers. You don't get the ability to configure servers and install servers. But today they have a large offering of tools from 2000, from later years. So yeah, Microsoft launched its cloud services in 2010. That's when Microsoft's Azure started, and then also IBM launched Smart Cloud in the year 2011. Okay, so if you think about what made this cloud computing easier, is the way some of the technologies have advanced in the past few years. For example, virtualization technology. So how many of you here know about virtualization? All right, so virtualization is the ability to, you know, make a single physical server into multiple virtual machines. So you might have all heard the term virtual machines. So what is a virtual machine? Let's
Uh,
say, yeah, go ahead.
yeah, it's a computer that you can access using your own hardware. It's another computer parallel desktop that you can access. It can be within your own PC, or it can be a remote desktop where the operating system is on the server and then you are using a client to access it.
Yeah, that's right. That's a virtual machine. So before that, we need to understand, earlier they were only physical servers. Okay, in the sense, physical server is nothing but a piece of hardware, like your desktop towers we had back in the day. You remember those? Some of you still might have your desktops. We have a CPU, right? So physical server is something similar to that, maybe much smaller than that, but much powerful. What is a server? A server is a computer. It could your computer could also act as a server, but in general, when we talk about a server, it has higher capabilities. Maybe it might have like 32 GB of RAM and let's say 16 cores of CPU. Okay, or there are even servers which have about 200 GB and 64 cores of CPU on the cloud. So earlier, you could only treat this entire machine as, let's say, one physical server, one server. You can only install one operating system, maybe Windows or Linux. So later came the uh, system called as hypervisors or virtualization software, where you could install some sort of operating system like VMware CSX. Okay, you could install ESX or Microsoft's hypervisor, and then with this virtualization software, you can divide this single physical server into multiple VMs. So multiple VMs.
Class. Class ఉంది. Class ఉంది. 1 hour ఉంటుంది మీరు కానీ
Okay, so what does this VM mean? This VM means it can have its own operating system. For example, this first box can itself have, let's say, Red Hat Linux. The second box can have, or second virtual machine can have Windows, and the third machine can have, let's say, uh, Solaris. Okay, and the fourth one again could have Debian, which is again another flavor of Linux. So one physical machine can be divided into multiple virtual servers, and each of them will act as if it's a own computer. So this is how the journey towards cloud. So what this made was, uh, you could now install multiple one server. You could use it to customize softwares on different VMs. So one could install multiple services on these VMs. So one could have your web server, one could host your database server, one could host your some middleware software. Okay, another one could be a redundant server. Redundant server in the sense the same server, like your web server, but in case it fails, it will act as your backup. So that's how the virtualization has changed it. So now you could divide one physical server into multiple virtual machines. Then the networking also bloomed in the sense that you could access resources from far afar, like from the other side of the world within like few seconds, right? Now we can access media like Netflix or Amazon Prime. The data centers might be wherever, but we are accessing it within no time. That's improvement in the like network connectivity across the globe. Sorry, this is not one here. Okay, so advancement in the virtualization and storage technologies as well. So now storage is not only much faster, but it is also cheaper. So these technologies have given rise to this cloud technology. And another thing is, as I said, the network connectivity across the globe. Now the speeds could be like what, 1000 gbps. We're talking about 100 gbps is like very common these days. um, and businesses looking for ready-made and abstracted computing resources without actually worrying about the underlying technologies. So what does this mean? So there are businesses which really are concerned only about how to deploy their software, how to have their software running fast and quick without worrying about, oh, I need to set up a data center and the networking part. So what this cloud does is it basically takes away all this. When I say abstracted, it means that it is hidden from you. All that you need to do is select a few options within your uh, website, the cloud provider's website. So that's how the cloud has has come up. So the increase in the virtualization technology as well as the advances in the network connectivity kind of propelled this cloud usage. Now we see that a lot of businesses are adapting cloud, and it's growing fast. Okay, any questions so far? Okay, I'll take it as a no. Okay, so there are some characteristics defined by National Institute of Standards and Technology about what makes cloud computing. So I'll share this deck, but not bore you with all this stuff. So one of the important thing is to be able to give the user uh, the full control to install or create resources without intervention by the person at the cloud provider. Meaning, like earlier days, you need not call the customer care of the Azure or AWS and say, hey, I require two AWS two virtual machines, or I need so much storage. Instead, you would go into a web service or web server and start creating your own resources. That is self-service. So broad network access, again, these have to be accessed through multiple ways. One of them important is through a web browser or a mobile app, and also through your thin clients. Like you might have an dedicated app for them, or you give some command line tool. And what is resource pooling? So to create a pool of resources on multi-tenancy model so that multiple customers can access the same resources, but with complete isolation. Different physical and virtual resources should be dynamically allocated and reallocated as per customers' demand. So going back to the virtualization analogy or virtualization thing, if you see, uh, today we might create some resources and some other user might create some other resources. They might be created on the same physical server, but we don't know. We'll see as if they are two separate entities. So that is what we call it as resource pooling and complete isolation. So you use the same amount of resources for all the customers, but for them it's their own cloud. It's their complete isolated unit. Okay. And rapid elasticity. So we spoke about this in the demo as well. So to be able to scale up and scale down as per your demand. Today you might be using 10 servers, but tomorrow you should be able to get back to just 4 servers or just 2 servers within no time. That's the rapid elasticity. And the fifth one is very important, measured service, meaning you need to give a cloud provider needs to give the user or the consumer the ability to uh, understand what is his utilization, where he is spending his money. So how much time he has used so and so resource, how much throughput or how much input and output has gone through for that service, and how much is billed to each service. So maybe you are a IT organization that serves multiple clients. So you would need to have a separate billing for each client. Suppose you're hosting their services, you have 4 clients and you're hosting their services on Azure or AWS. So one of the important characteristics of cloud is to have a measured service where you give users the high level visibility of you know uh, how he is being charged for what he is being charged. Okay, that's the measured service. Okay, again, these would be some of the repetition, but why cloud? No upfront cost. You can start running your application without paying for the infrastructure. So you need not pay for anything when you begin. You'll start only paying when you start using. Elasticity, scale up or scale down on demand. Okay, within a few seconds you could go from 4 servers to 10 servers, and you could also go from 10 to 6. Okay, availability across multiple geographic regions. So imagine you are a business that are running across the globe. You have some businesses in North America, US and Canada. Maybe you have some businesses in Middle East, or some clients in Middle East, some clients in say Asia Pacific, Singapore, Hong Kong, and these places. So cloud gives you the ability to provision your data, your resources in any of these regions. You could provision them in US, you could provision them in Mumbai or in Hong Kong, or even somewhere in South Africa. So, and also somewhere in Australia as well. So this gives you the flexibility to create resources across multiple geographic regions. Imagine this on a private data center scenario where you will have to create your own data center. In that case, you will have to go to each of these countries, hire staff there, rent data centers, start your process. So that involves a lot of cost. But now you could simply create a resource in Australia without having to pay anything. And as I said, pay only for what you use. So if you remember the warehouse analogy from our demo, where I said if you are into retail business and you have a big godown, so you'll only pay only for how much you use instead of paying for the entire warehouse. And detailed visibility into the usage and pricing. So you will have very granular view into what is your utilization of resources and what is their price and how much you're paying for each of the client or each of the area. Highly secure infrastructures, just because of the sheer scale. Suppose if you have to build your own data center, okay, you'll take your own, what do you say, data center, a physical building. You'll start installing your servers, you'll have power backup, and everything is in place. But still, there are a lot of security hardening that you need to do, both at the physical level. That means your wires and all should not be cut off, and also at the network level. In the sense, you should prevent the bad guys from hacking into your computers, right? So for that, since these cloud providers have huge scale, they also invest on products, or they themselves create some products which will keep the network attackers at bay. In the sense, your systems cannot be easily compromised at the networking level or at various other levels. Maybe if you install a poor software which is open to bugs, then you're responsible. But at the networking level, but at the infrastructure level, the cloud providers really ensure that your infrastructure is very safe. That's another reason why people are going for cloud. That's why people are going for cloud these days. And there is another reason, like if you want to host some data related to, let's say, health sector, we call it as PHI, personal health information, or PII, personally identifiable information. These are very sensitive data. So if you also build up a data center, you will need to go through some certifications. Some organizations will have to certify that your servers are very safe. So that certifications are already procured. I mean, these companies are already certified by those compliance agencies. So in terms of compliance and regulation as well, you have some advantage. Yes, there's some trade-off. Some banking companies would not put their highly sensitive data in public cloud, though they are very secure. Maybe that will change in the future as well. Okay, any questions so far? Okay, I'll move. So when we talk about cloud, there are various types of services, various levels at which you can manage your resources. So to begin with, there is IaaS. That's nothing but infrastructure as service. So this infrastructure as a service, means you could rent infrastructure, meaning what could be that? You could rent virtual machines, you could rent storage, you could rent load balancers. If you don't know what this is, no worries, we'll talk about that. You could rent something like a firewall. Okay, so these are all infrastructure pieces, right? Your virtual machines, your storage, okay, your load balancers. So all these could be rented on demand. That's part of IaaS. So what happens here? You simply, you know, provision a virtual machine and start, and they come with some pre-installed operating system. Okay, then you'll start building your own application. So you start installing your application, deploy the code. So what happens here is you'll not only have to provision the virtual machine from the Azure portal, you'll have to log into them, install the application, deploy your code. Similarly, with the case with storage, you will take some disks for rent. Okay, just like your hard drives, these are virtual drives. You take some virtual drives, maybe attach it to your VMs, okay, and format it and start using it. Okay, here you'll have a lot of management to do, like you have to uh, take care about your application updates, your also operating system hot fixes, because um, people who have worked with Microsoft or even Red Hat, they know that every now and then your computers need to be patched. What do we mean by patching? So every now and then people identify some vulnerabilities or some risk areas which need to be fixed with a new software patch, or you just make some changes to the existing software. So this patching and everything has to be taken care by us if we actually go for the IaaS part. That's the infrastructure as a service. But what is the advantage? It gives you the maximum control. So you can install your own operating system, or you can choose what operating system to be installed. You could uh, you could configure your software the way you need. If there is any tweak that you need to do to your virtual machines, like changing some settings, you could do it on infrastructure as a service. Okay, next service is what we call as PaaS. These are called as developer services for a reason. So in this case, suppose you are a developer, and you don't want to worry about anything like virtual servers and your operating systems and the runtime and all this stuff. You're simply a developer, and you want to you have a nice idea and you developed a code, and you want to directly deploy it without any headache of creating servers and installing software and all that stuff. In that case, PaaS is the best solution. Okay, so you simply give your code to the cloud provider. Okay, sorry guys. So second one is PaaS, platform as a service. So in this case, there's nothing you need to do. Just hand over the code to or deploy the code on the cloud provider. So you just need to build a code, give it to the cloud provider like Azure or AWS. They will install the code. So all these things, the virtual machine, the underlying operating system, even the application like your Apache or Tomcat or IIS, everything is part of this platform. All that you need to do is give your code and they'll deploy it, or they'll give you a way to deploy it on their platform. This is platform as a service. So there are some services like Azure apps, okay, which, and if you come to IaaS, it's nothing but virtual machines and all that stuff. So here your control is very limited. You can only control your code. What is the operating system? What version of the application your code is being run on? All that you don't know. It's all taken care by your cloud provider. You can only manage your code. You can only make changes to your code and deploy it on the cloud platform. So here you have little very less I mean, not very less, but less control over what's happening underlying, but you have also less management pain. You need not worry about the patching your servers and keeping your applications up to date, and all this stuff is taken care by the. So this suits some business cases. Like as I said, if you are a small startup, you have a nice idea about a piece of software, you think it will do well, then I think PaaS is better. Without, but uh, typically those codes that do not require much custom changes. Okay, so that's about IaaS and PaaS. And next one is we have something called as SaaS. Okay, it is nothing but software as a service. Here let's take the example of Google Drive, right? So if you want, all of you might be using Google Drive or some version of storage like Dropbox or anything, right? So if you look at Google Drive, all that you need to do is go to that app on your mobile or on the uh, on your laptop. Just go to drive.google.com. You don't install anything, you don't build code, you just, you know, simply start using the service. So the vendor itself or the cloud provider himself will give you everything. You, all that you could do is, log in and start using it. When the in the organization level, let's talk about things like, if you take about Visual Studio Team Services, we talked about, right, the Azure DevOps thing, that itself is a SaaS offering, meaning you don't have to install anything, you don't have to run any virtual machines. Everything is taken care by the customer, but you'll pay for the usage. For example, if 10 users are added and you're using like 10 GB for each user, so you'll be calculated for that amount. Okay, just like your Google Drive, they'll give you a minimum of 15 GB, I guess. But after 15 GB, you'll start having to pay for every GB you use, right? So here you don't have any control, minimum control, and no management overhead. You need not manage anything. Everything is managed by the vendor, including the code. So what are some of the use cases? For example, you are a startup, you don't want to worry about creating email server and a uh, you know Google Drive kind of thing, then SaaS is the best thing. Just use Google Suite. Okay, or some organizations, they want to have a learning portal. Okay, every organization has some learning portal, right? They might host their internal and also external trainings. So sometimes they say, okay, why do we have to worry about creating a new software, maintaining it, maintaining some developers? Let's give it to some organizations like SABA. You might have heard of it, right? So SABA will give you will create an account for you, will give you access to their tool, and you will start using it. That's SaaS. As I said, each of has its own advantages and also its trade-offs. Okay, so the third part is SaaS. No control over infra or code, no management overhead. Okay, is it understood? So these are the different types of services. uh, the cloud providers offer today. So these are categorizations. So some might fall between, some might sound like IaaS, but they might fall under PaaS. We need not really worry about it, but we just need to understand. Okay, as a DevOps engineer, you would need to mostly concentrate on your PaaS services, that is platform as a IaaS services, infrastructure as a service, because as I said, platform as a service, there is very minimal administration from your end, right? Minimal administration. Uh, so here's where we control the amount of resources we create and how do we create and where do we create and all this stuff. Okay, so that's why we will focus mainly on IaaS servers like the virtual machines, the virtual networking, okay, storage, load balancers and stuff like that. Okay, SaaS, there's nothing to worry about, mm, because everything is taken and we need not learn anything. Maybe we'll start using one of those SaaS tools like Slack, which is a you guys might have heard about Slack. Slack is like your Microsoft Skype but with much enhanced features, and they have some free accounts where you could where you could use for like up to 10-50 users without having to pay anything. Okay, 10 to 50 users. uh, that's the SaaS part. But yeah, there's nothing to learn for us because if you're because here you're only a consumer. So that's how the pyramid is. This is so the infrastructure as a service has maximum control and also maximum management. You need to do the all the management going. Yeah, so this is another overview. So as I said, extensive connectivity. So your cloud services should be able to be connected from a phone like your Google Drive or tablet, even desktops and servers. Okay, sometimes you need to connect to your server to access some data. And yeah, again, compute, storage and network, these three form the core of your infrastructure as a service part. Compute is nothing but virtual machines which will come with your RAM and CPUs. Block storage is nothing but your disks. Okay, the additional disks you need to install. And networking is all about your virtual networks, subnets, the load balancers and all that stuff we'll discuss. Okay, when it comes to platform, like you have object storage, like identity and access management, there is some runtime like Java runtime or .NET frameworks, queue systems and databases. And applications, you have monitoring tools which you could simply configure. And news content is a SaaS application. Collaborative tools, I just spoke about Slack. You could also think about Microsoft Team Services. Yeah, communication again, maybe Skype, some finance tools as well. So these are some examples for your various cloud services. Okay, guys, any questions?
Kiran, what is serverless?
So serverless, you could call it as a part of platform as a service. So again, serverless has some business cases. For example, you need to run, say, one job every day at a particular time. You need to take a backup of say your databases. So for
Okay.
that, you need not create a new server and every time manage that. So you could simply write a function like Azure has its called as app functions. So you could simply write a function and say that okay, at every day in this time take a backup.
Uh-huh.
So what this serverless does is at that particular time it creates a new virtual machine, does the job for you, and once the job is done, the server deletes itself. Okay, or the service deletes the container, so you no more have that server. So that way you can save money. So for batch what you call batch workloads or the um, what you call scheduled jobs, the serverless is one of the has some of the use cases. Yeah, serverless I would
Okay.
say would fall under pass because you don't have maximum much control over the infrastructure.
Okay. Okay. It's not like another cloud service, right?
It's a cloud service, of course it's a cloud service.
Okay. Okay. Oh,
Yeah,
that's cool.
serverless has been popularized only by cloud servers like Lambda functions in AWS,
Okay.
function apps
Like
in
what I mean to say
Azure.
is like IaaS PaaS and serverless is another service or it's a part of a
It's
PaaS
part of
service.
PaaS, you could say, platform as a service. Just think
Okay.
about it. You have you don't really manage. what's the operating system and what's the application that is running on the operating system. You only manage your job that you want to write. So that falls under PaaS, right? So
Yes.
these, so just remember these things, okay? What do we do here? You don't know anything about the infrastructure. Here you know everything about the infrastructure. So a serverless app is more like a PaaS rather than a IaaS. Okay, so it falls under the cloud service itself. Any of the cloud services must fall under these three services. Okay,
Okay.
some of them might have some administration overhead, but still you have to think about the basic characteristic. Are you worrying about the underlying infrastructure? If not, it's a PaaS. Okay,
Okay,
so
Kiran.
if you don't know anything about even if your code is not yours, then it's a SaaS, obviously. So yeah, consumers are in total control and there is management overhead. So you have total control, but it also has the management overhead, meaning you need to have staff to manage those servers. From security patches to OS upgrades and backups, consumers are responsible to keep their systems healthy and up to date in IaaS. Okay, like what are the examples? Azure virtual machines, desks, and Azure Kubernetes services. And SaaS, minimal control and less management overhead. So as I said, SaaS is all about taking the application from a web console or like something like your Microsoft Word. You just start installing it and using it. You don't worry about the code. You don't worry about the infrastructure. PaaS. Oh, okay. I think I made it a blunder. This is PaaS and this is SaaS. Yeah, consumers only. Let me correct it now. This is PaaS actually. My bad. This is SaaS. Okay. So at least now you know that I've created and did not copy it. Okay. So PaaS, you have very minimal control and less management overhead. SaaS, no control and zero management overhead. That's what we talked about. Okay. So yeah, just remember these things when you talk about. There might be various services like uh, Azure today has so many services in IaaS and PaaS, mostly in PaaS, where you need to do minimal administration, but you could deploy your code easily, like serverless applications and stuff like that. Okay, what type of service do you choose? Okay, you suppose you're starting a new applications like new business and just let's say like Flipkart, okay, or Ola. So what is the right type of service? Do you need to go for IaaS, PaaS, or SaaS? Okay, it depends, right? Um, so if your software needs some custom changes to your operating system, you need to change some settings in operating system. Suppose only then your application works, or you need to have a specific operating system with some custom changes and this and that, then IaaS would be right choice. You will be in full control. And also if you want to be in total control, like whether you have to upgrade the runtime or not, then it's the right choice, IaaS. But another example, I said you are a developer and you have a concept and this can run simply on any of the operating systems. You need not do much custom tweaks. Then PaaS is the right solution. You would only worry about building your code and taking that code and deploying it on the cloud. You don't have to worry about provisioning virtual machines, provisioning disks, and all that stuff. SaaS would be right for some use cases, like I said, like a Google Suite for a startup. Why would a startup need to worry about creating its own mail server, its own storage like Google Drive? Okay, instead, or even access management. If you take Google Suite of applications, it will come with its own access control. So you need not actually create a new Active Directory on your own premises. So that suits some business cases. So how do you choose the right service? It depends upon what type of applications you're building and what type of control you want to have, and how long do you think your application lasts, and also the cost factor. These are various things you need to keep in mind. I mean, when I say we, not we, it is chosen by the architects when they are building the infrastructure. Okay, just a short note about cloud wars. How does AWS and Azure compare today? So as I said, AWS began much earlier. It started rolling out cloud services as early as 2002, initially internally, then made it public in 2006, and obviously it has clear lead over the other cloud providers. It is the leader in the market, undoubtedly. Um, Azure is picking up the pace and growing at faster pace than Amazon and far ahead of GCP. So though Google has started even before Azure, it did not pick up much. Okay, there are some organizations that stick to GCP, but mostly it's between AWS and Azure. So Azure is today the second most leading cloud provider in terms of not only what do you say services, but also the market share, the amount of customers that are using Azure. What makes Azure competitive, or what is driving its growth is, as you know, Microsoft has various services like its uh, operating system, its own hypervisors, its own communication tools like Microsoft Skype and many other stuff, right? So some of the existing customers might think, okay, I already have good knowledge of Microsoft. I have some working agreement with them. Let's continue with them and move on. If I'm moving to cloud, okay, I'll move it to Azure itself instead of AWS because they already have a lot of uh, partnerships with Microsoft. That's one of the features. But that doesn't mean people who have been using Microsoft will not move to AWS, but this might be definitely a factor in people making their choice between AWS and Microsoft. Also, Microsoft says that their VMs, which is part of IaaS service, are much cheaper than AWS if you're going for Windows. Obviously, because Microsoft can license its Windows for free or very minimal price. So they minimal. They some of the VMs at Azure are 5 times less costlier than AWS. But again, people might vary. There's no clear-cut answer on which is cheaper. It depends upon service to service and use case to use case. Okay. So these are some of the analysis done by this organization called Canalys. Okay. So you could see they have gone 41% up. So definitely it's a clear leader. AWS is definitely a clear leader because they have been there from the beginning. Microsoft doesn't have that much share, but their growth rate, if you see, it's 75%. So the year-on-year growth is quite fast. And GCP, yeah, it's trying to catch up. Its growth rate is also high, but still the adoption, I would say, is slow for GCP, Google Cloud Platform. Okay. And yeah, this is the market share as per some research from Gartner and Goldman Sachs. Okay, so this is about Alibaba. These are Alibaba and GCP are at one level, trying to cope up, and Azure you could see is growing faster, and others have been coming down. Meaning Heruko. There was one PaaS provider, and there are certain others. Uh, there maybe IBM Cloud and all this stuff. They're coming down, but you know AWS and Azure continue to grow. That's about the cloud market share. And yeah, that concludes this presentation about cloud in general. So I'll open up for questions. I know we are over the time, but yeah, uh, I'm here for your questions.
No, from my end, Kiran.
Okay. All right. So as I said, we still need to understand. I mean, we still need to come to a conclusion whether we will go for Azure DevOps or Jenkins plus GitHub stuff. Because you could check your market openings today, and you might most likely find more about Jenkins and GitHub than Visual Studio Team Services. So let me know. I will start a Slack channel. Maybe I think you've all given your email addresses to Lakshmi ji, and I can take your email addresses and create a Slack channel where we could all interact and ask your questions offline. Okay. Uh, if I create WhatsApp again, it will be spammed with messages and all that stuff. So let's start using Slack. Slack also has their own Android and iPhone apps, iOS apps. You could also start installing on your phones and start using it. So Slack is a good tool for communication and collaboration. You could share documents easily, and also there are a lot of features. All right. if we do not have any questions, we'll wind up. Tomorrow we'll begin with Azure. How does Azure portal?
Kiran, from the training part, what is the project like? It will be some. Are you sharing any project for that? Azure DevOps integration thing.
E- I mean,
Generic
not
question.
just Azure DevOps, not just Azure DevOps, even the Azure. First, as I said, we'll do everything manually. We'll learn bits and pieces. Not bits and pieces, in chunks. Like we learn first VMs, then we learn virtual networks, disks, and all that separately. And later we'll combine together this as one project. We'll begin from scratch. Okay.
Okay,
So how do we automate creating servers? How do we automate GitHub integration and everything? Okay, so yeah, we'll do this together as a project.
okay.
Okay.
All right, Kiran. Kiran, sorry.
Yeah. Okay, guys, thank you so much for your time. See you tomorrow morning.
Bye, Kiran. Have a good day.
Thank you.